Oh, blast off. Okay. So it is the 6th today. We are still doing the same thing as we did yesterday, but it is the 6th. Different day.
Yeah, when is 1.3 and 4 going to be gone?
I'll change it. It'll be tomorrow evening. And I think it might already be set with that due date. But I have not logged into schools yet, so we cannot waste any more time on that. Monica? Yeah, we did keep, change, flip. Because the ratio that we start with is actually a division. So this right here, and on my paper it's color-coded. Yours it might be a little bit more difficult to see. But when I have a fraction over a fraction, I know the top two numbers are the original fraction. The bottom two numbers are the second part of the ratio. So I would like you, if you have space somewhere, this would be much easier to deal with if we...
As 3/4 divided by 6/7.
If we write it out horizontally, 3/4 divided by 6/7. Now I want you to understand why they did what they did, but let's work through our method first, and then maybe we'll understand their process. So we already said that we're going to apply keep, change, flip based off the fact that this is a fraction divided by a fraction. Are you good, Saul? Do you have the right notes or what? We passed them out yesterday. They're stapled together.
1.4?
1.3, 1.4. They're stapled together.
Oh,
1.3. Right here. Front. So, we keep, change, flip. This becomes 3/4 times 7/6. And we get 21 over 24. Those can be reduced each by... And what can they each be divided by?
7.
7. And we get 3 over 4.
Wait, no, that's not correct. That is not correct. 7 times 4 is 28.
What can they be reduced by?
Oh, I know this one. Wait.
4.
Ozzy raised his hand.
Yeah, it's
3. Thank you. I think what someone thought of was this divided by 3 will give me 7, and then they accidentally flip their numbers around. If I divide by 3, I get 7 over 8. I was going to see how long it took somebody to catch that mistake. So, that's our method. But why did they multiply by 28? Can anybody figure out why they multiplied by 28? Katia? They took, now if you read this would make sense. But what they did was they look at each of the denominators, our 4 and our 7, and they find the least common multiple of the denominators. So if you wanted to, you could, when you have a fraction compared to a fraction, look at the two denominators, and a lot of times to find the least common multiple, you could just multiply them together. That might not be the least, but we're probably going to have to reduce anyways. So we multiply by 28. Now this is really like 28 over 1. So this would become 3 times 28 over 4, and then that reduces to 21. This would become 6 times 28 over 7, and then reduces to 24, and then we reduce our fraction out to the 7/8. Any? Yeah, so I disagree with this process, but it does work. So this is like the whole lot of right ways to get to Florida. I would disagree if you said drive to Texas, then drive to Florida. But you could still get there. Monica?
I didn't get it. How you did the 28 thing.
So if we, and actually I'm going to shift this over so I can show this a little bit more. This times 28 on the top becomes 3/4 times 28 over 1. We chose 28 because it's the least common multiple of 7 and 4. So the point that we're trying to do here is multiplying by 28 will actually get rid of my denominator of 4 and just make this number bigger. So that becomes 60 plus 8, 16, 24, 84 over 4, which becomes 21. My denominator was 6/7, and I multiply by 28 over 1. That becomes 128 times 6. 48, 168, I think, if my math is right, and that is an if. But either way, that should become 24. I hope that math is right. So then my fraction becomes 21 over 24, and then I can reduce it.
But why does it work when you multiply?
Because it's the least, it is a multiple of 4, and it's a multiple of 7. Because here, if I multiplied by 4, it would get rid of the 4. If I multiplied by 7, it would get rid of the 7. But I can't do either of those Because if I multiply by 4 on top and bottom, it will screw up my bottom. If I multiply by 7 on bottom and top, it screws up my top. So I have to work up the multiples of 4 and 7 till I find a common multiple to make this work.
So when you're getting rid of
So can I probably make this easier? If this process doesn't make sense, don't do it. I don't think this is an easy process. This is a more complicated way to solve this, but it's another option. So if this doesn't make sense, don't use it. Choose a method that does make sense.
yeah, but just one question. When
Okay.
you're like trying to get rid of something, but like when you have a division problem and you want to get rid of the number,
Get rid of the denominator.
you multiply. You can multiply with any of its multiples.
Mhm.
also, and not
Because
just the number.
this got rid of the 4, but it made my value bigger, which is okay. I started with 3. So since this 28 is actually 4 times 7, because that's what 28 is, the 4's cancel each other out, and the 7 multiplies to my 3 and makes my 21, not my 84.
What?
What about the multiplication?
What do you mean?
4 times 7. So what happens with the multiplication?
So we can honestly break, like, multiplication is commutative. I can move things around however I want, right? Because 2 times 3 is the same as 3 times 2. So I can actually write this as 3 times 4 times 7 divided by 4. It doesn't matter when these things happen. So I could multiply all these, then divide. I could divide, then multiply. It doesn't matter the order. But again, if this doesn't make sense, I just showed it as another option. So, solve these the easiest way that you think. I'm going to show one of them using that method to try to make this make a little bit more sense. To get rid of my denominator in the numerator of 3, I would need to multiply by 3. But I can't do that on the bottom, because then I would end up with 3/5. To get rid of my 5, I could multiply by 5, but I can't do that on top, because I would get 10/3. So what could I multiply them both by?
15.
15. Now again, if this doesn't make sense, don't use it. That will make my numerator 30 over 3 and my denominator 15 over 5, because this 15 is really 15 over 1. This becomes 10, and this becomes 3.
That's super annoying.
So, this is true. It does work, but it's kind of awkward.
Kind of.
So, it all goes back to your brain. How your brain is wired, how you learn things as a small child, will depend on which method you prefer. There is no right or wrong method. They both work.
Are those the only like 2 methods that can be used?
I mean,
Like the 2 main methods?
there's, if you want to be technical, we could probably solve this infinitely many different ways. But some of them would be ridiculously complicated that is absolutely unnecessary.
So, like making it into decimal.
Well, I mean, I'm talking ridiculously complicated. I mean, we could multiply both of them by some huge common multiple and make those fractions giant and then reduce it down from, like, there's just a lot of options in math. Always, there's a lot of options. So if I do this one out horizontally, haven't gotten these out in a little bit. Solomon, what's the first thing I would do to this vertical setup to try to use keep, change, flip to solve here?
No idea. I'm not very good at math. I didn't write it down. I needed help with it. I didn't understand the other thing.
Refer back to essentially what we did here, or you didn't write the word here. Or here. Here you have the work. We had a ratio involving 2 fractions. What did we... So first it started vertical setup. what did we do to it first? So it started fraction over a fraction. We then took it and did what? If it's not vertical, we made it a division problem, yeah, but it starts at, this is a division problem. We took the vertical setup and made it horizontal. I was going to have you phone a friend. I'm just trying to get you to realize, like, you got to be paying attention and asking questions. If you don't know what's going on, guys, you got to ask questions. There are some of you, and I see it on your face, that sit there and don't know what's going on and are refusing to ask questions, and it's biting you in the butt when we get to these assessments. So, thank you, Saul. When we take it, we set it up horizontally. So we do 4/5 divided by 6/7. We're then going to, yeah, Elena? We can do the keep, change, flip. And this becomes 4/5 times 7/6. And by the way, some of you, if you write too big for my notes pages, you can always, there's tons of extra paper over there. Tons of extra paper over there. Then, Sean, how do I multiply through fractions? Straight across. We do not need common denominators. A couple people are still trying to use common denominators when multiplying fractions. That is unnecessary. So 7, 14, 21, 28. 5 times 6 is 30. I can reduce these guys by, Julian, what can I reduce by? I can reduce by 2. Can I reduce by anything bigger? So it doesn't really matter. We can reduce by 2 and then reduce again if we need to. But if you had already quickly identified something, that'd be cool. But yeah, 2 works. So if we reduce by 2, it becomes 14/15. Then we say, do 14 and 15 have any common factors? No. We land at 14/15. This is true. Try C on your own if you have not done it yet. If you have, go ahead and move on. If you would like. You want to go up and write it? Go write it. Show all the work.
Okay. Can I do the gauntlet? Can I do the gauntlet? Alright, I just said it.
Alright, we're going to do cards for Got It to give people options. What? No, you've got C. C is you. But now there's too much competition. Alright, just making a little bit more sense. So all we're really doing is taking the ratio and showing that this main fraction is really a division bar. We set it up as a division. You change flip, and I would maybe put KCF or draw an arrow and put KCF so you remember why we did that, and then just simplify.
So,
looks like 1/8. Will you go fix your 9? Yeah, so then it becomes, you do keep change flip just like Don, or
It
just like
doesn't
Jeremiah.
matter though. Yes, it does. That doesn't. Look, 36/24.
Reduce it. Always reduce.
Is that 24?
Does that make sense?
20.
How are we doing over here, guys?
Okay, half that.
Try the Got It on your own. If you've done C, try the Got It. While you're giving Dom a hard time. What's up? Oh, you just like wanted to do that.
You mean Jeremiah?
Sorry, Jeremiah. You guys look too much alike. I know who's who when you're right next to each other, but for some reason my brain can't keep it straight. Dom and Jeremiah, but that's just in my brain.
They do look alike though.
They have similar facial structures.
They
They
have
do.
the same hair color.
Okay, Andrew. Sorry, are there? Hold up. Are there any questions on the Got It or on Part C?
Are we allowed to reduce it to 1.5?
Yeah, you could make it 1.5. That's totally fine. Or 1.5. 1 and 5 tenths if you say it properly.
The reason I stopped at 36/24 is because 2/3 is less than 1 and 36/24 is over 1, so there'd be no way, even if I reduced it, that it would be true.
I agree. But we always want to look at fractions in simplest form. And equivalent fractions is a skill of this chapter, so reducing is good practice for finding equivalent fractions. Andrew, do you have interest in doing the Got It? All right, come on up, man. Did you just call me Sherd? Oh, I was about to say, I look nothing like Mr. Schmidt.
You think I look like Jaheen? That's a good
No, you look more like Zion than Jaheen.
Yeah.
Just because your guys' hair.
Jeremiah looks like Jeremiah.
Mr. Hudson, I can't tell you how many times I called Mr. Smith. What do I have?
Every time I go to his old class,
He's got like
I
5
teach him. I'm like, oh no, wait,
Jeremiah always mix you guys up.
You know, Mr. Smith has a deli. His family has like a
Yeah,
restaurant.
he told me.
Deli place to get like sandwiches or.
Mr. Smith.
I when I first heard it, I thought he was
Yeah.
The squad was trying and then my dad.
All right, now hold up. Let's check Andrew's work. Let's check Andrew's work. Andrew, talk us through your process.
So I was doing it was supposed to be 3/4 divided by 9/10, but when I changed that to the 3/4 times 10/9, then I got 36, and then I reduced that to
What did you divide by here?
divided by yes.
So you said 36 divided by 6 is
Or no,
18. What is 36 divided by 6?
36 divided by 6 is
6. So this becomes
18.
5/6. Or you can say 5 to 6 or 5 to 6. Any other questions on the got it?
I think we got it.
Ah, that's the point. Like the decimal. What's up?
Can I do the next one?
Do you already have it done?
No, but I know how to do it.
He does have.
So I'm going to do the example. I might let one of you guys do the got it. But I want to do the example because there's a trap door here. I do. Trap doors are always fun. Indiana Jones, great movie. Where or what is the trap in this question? They've set up, because if you just keep rolling like we've been doing, you're going to fall in the trap. Sam, what's the trap? They're what?
They're mixed numbers.
They're mixed numbers,
And the units are different.
and the units are different. To make a ratio, and especially to make it in simplest form, but a ratio is unitless if we're only talking about the ratio. If we're only talking about the numbers. Now you could put units in your ratio, but we would prefer to make the units match and just make our ratio unitless. So, is it easier to turn bigger units into smaller units, like feet into inches, or in this case, yards into feet? Or is it easier to turn feet into yards? Think about this. Which would you rather have? Smaller, maybe partial numbers, or bigger, maybe whole numbers? Monica, what do you think? Which do you think is easier?
I would think making bigger to smaller because, like, smaller to bigger, you might have like half.
Yeah. Bigger numbers or whole numbers are easier to work with. So if we want to go yards into feet, if I start out with 53 1/3 yards, and I can put that over 1, how do I convert that to feet? What is my conversion factor here? Elena?
Isn't there 3 feet?
There are 3 feet in 1 yard. Now, where do I put my 3 feet and where do I put my 1 yard? You already gave it to me, so let's see if you can finish it out.
You put your feet on the top.
Why? I agree.
Then they can cancel out when you cross multiply.
Yeah, not cross multiply, but the units that are across from each other, because you're not multiplying across. You multiply across only in a proportion, right up here. But when we have fractions, by the way, guys, keep change flip is right here. If you haven't looked at the posters in my classroom, the keep change flip process is literally right there. The yards divided by yards, anything divided by itself makes 1, and that 1 doesn't have a unit. So this will become, well, break this up. What's 50 times 3? 150. What's 3 times 3? 9. 1/3 times 3? 1. add these up, and we get 160 feet over 1. Now, this would be feet yards over yards, but then those would cancel, so we don't even need to write it.
So is it 1 yard or 1 foot? Like that it's over.
It's 3 feet in 1 yard. Now, I could flip this and say there's 1 yard in 3 feet, but then my units wouldn't cancel out correctly.
But like,
Are you putting one of those in the
100
emergency thing? Thanks. It's a good idea.
160 feet over 1 of what?
Nothing. 1 of just 1. Because my units have canceled out. So really, I don't need that over 1, but since we were working with fractions, I figured we might as well leave it in fraction form. But this really just simply becomes 160 feet. Which 1 apostrophe is foot or feet. 2 apostrophes is inches. So now we can actually set up our ratio.
Wait, so for that,
Dom?
like, I'm kind of like, you put the bigger number, you multiply that by like a smaller number, or what?
So which number is bigger has no relevance to what we're doing. How we chose what we did was since we started with yards on top, and I want to turn that into feet, I have to get rid of yards. So when I put a unit over top of itself, they cancel each other.
So just getting rid of
It's getting rid of the yards. Now I could have turned this into inches if I wanted to, but this would have been 36 inches. Then I can turn it into any unit I want. I could turn it into fingernails. Like literally, you can make up your own. You can say, how many fingernails long is this field? Like, it doesn't matter. You could make any conversion factor you want. All you care about is canceling out the yards, and whatever you put up here stays with your answer because it did not cancel out. Are we cool on our conversion?
Yeah.
Now, it says, what's that? Not a problem. I just thought you had something to contribute. Width of the actual to width of the poster. So we want actual, and if I was you, I would write this so you remember what we're doing, to the poster. Did I hear Mr. Hudson? Someone needs something. What's up?
How come people make symbols for things and like the old ones? Like you said, one apostrophe means foot. So why did they still have the FT symbol?
Because it depends on how like quickly you're trying to write, how abbreviated you're trying to be. If I'm working with labels that all have like yards has no abbreviation like the apostrophe. Yeah, but what? Not really because of that. Just there is no other symbol. So somewhere in our American system, we said, oh, I want to be able to represent inches with 2 ticks, probably because it's a keyboard key. And I want to be able to represent feet with 1. But yards, forget it. We don't care enough about yards. We don't have any other shorthand. So it's just options. There's no, like, I don't know where the reason is. If you want to look that up, that'd be cool. I don't know where this even came from. I just know it's a generally accepted thing that we use. So, set your actual, which is 160 feet, compared to 1.5 feet, which I'm going to go ahead and make into fraction form. What's my 1.5 in just fraction form, Andrew? 3 halves. Careful how we say that. Then, I'm going to identify this is really division. This can really be a fraction.
Whoa.
Because if I had a calculator, I could do 160 divided by 1.5, right? Pretty easy. But if I don't, or if I just want to use my brain because I like that, we now do keep, change, flip. We get 320 over 3, which is going to reduce to 106 and 2/3. That doesn't really reduce out nice. Yeah, it'll be 106.6 repeating compared to 1. So what this is telling me is the actual field is 106.6 repeating times the poster.
Wait, what poster?
So this is a poster. I just chopped off the rest of it because I don't like to print lots of ink. It just wastes our resources. The more toner that we go through, the more it costs. The higher your student fees are. It all trickles down. Julian?
Oh, wait, never mind.
Now, I could leave this right here and use the ratio 320 to 3. Because this reducing isn't really that simple. And since it said fraction in simplest form, we could just leave it here. But if I want to make a raw comparison of one of this compared to that, what's the multiplication, then I've got to take it down to using my 1 for the, normally we do it for the smaller. Because we say it would take 106 and 6 forever repeating to make, or sorry, it would take 100, let's just round this. It would take about 107 posters to do the whole field. Jeremiah?
Can you program our calculator?
To do what?
I don't know, make it like a tablet.
No, I can't. I can program it with what you want to do with math, but I don't know what you're talking about. Do we need to do the got it, or do you think we're pretty comfortable that we would need to convert units? And we're going to do more of this practice in 1-4, which is why I think we're probably good. Yeah, we can, let's review this then at the beginning of class tomorrow. I'll show the solve process for the got it. So if you want to try it on your own, make that kind of like a little challenge assignment for you outside of class. Now, unit rates with fractions are the exact same thing, except we have to get to what for one of my numbers? What's the difference between a ratio and a unit rate? Jeremiah?
Oh, I thought you were gonna ask something different.
The difference between a ratio and a unit. What's so specific about unit?
Please pardon the interruption. Aaron Fernando, please come to the office. Aaron Fernando to the office, please.
Acadia, what's really specific about unit rates?
Oh, I actually had a question about that.
Mm-hmm.
So how many users are in episode?
12. I don't know why I tried to use my hand, but 12. 12.
Everybody has 12 fingers.
Everyone has 12 fingers. Wait, what? So, unit rates. Ellie?
I think unit rate is, it has to be something over 1.
Thank you. Right here, highlight, circle, and star. Unit rate has the denominator of 1. That's the big difference. 114 now. Next sheet. Denominator of... So, right up here, and this is why I wanted to stop with this problem. This is not a unit rate. 320 compared to 3 is a proper ratio. It's not a unit rate. Our 106.6 repeated forever compared to 1, that is a unit rate. So the only difference here is I take my ratio and I have to reduce it to make the denominator 1. Jeremiah?
What's the difference between a ratio and a rate?
That's the only difference. Well, there's no difference between a ratio and a rate, but between a ratio and a unit rate. Unit rate tells me I have to have per 1 of something. So really the difference between ratio and rate normally talks about some quantity compared to a different quantity. A ratio, we normally have the same units. So a rate, miles per hour, feet per minute, students per class, chocolate chips per cookie. Those are all rates. Ratios are feet compared to feet, or inches on a model compared to inches of the actual. Those would have the same units. So that's a really good question. I appreciate that you asked that because I never really covered that. Rates are normally per. Ratios are normally just a comparison. So the biggest thing here is do whatever you have to make your denominator 1. Really, and what you need to write in here, what we should have done to turn 3/4 into 1, cross out this division, that's dumb. Multiply by the reciprocal. Because division by the fraction, we don't actually divide fractions. We don't like dividing fractions. It's too complicated. So when you would go to do 3/2 divided by 3/4, we would do keep, change, flip anyways. But we know that a fraction, when multiplied by its reciprocal, no change of sign, you only flip it, it becomes 1. So if I do the same thing on top, I will ensure that I get per 1.
But that's not the reciprocal of 3.
Yes, it is. 3/4. Its reciprocal is 4/3. All you do is flip it. You do not change the sign. The numerator we don't care about because we have to make the denominator 1. The numerator just...
Problem.
What are you talking about? This actual problem. We walk 3/2 of a mile, 1.5 miles, in 3/4 of an hour. I want to know how far I can walk in 1 hour. So I set up the ratio miles per hour, which is really a rate since there are different units that can't match because I can't turn hours into miles. So there's my big difference. To turn 3/4 into 1, I multiply it by its reciprocal, but I have to do the same on top and bottom. I know this is not the reciprocal of the numerator. It shouldn't be. The numerator just does what I make it do. Are we good?
Yes.
This goes back to I think you ask questions before you take the time to think about what's happening. You're just so chomping at the bit to want to and I love your participation, but you got to actually think it through before you ask the question. Because that's why we're moving so slowly. So, try our example here. If we have 3/4 cup of dry milk to 6 dog biscuits, people every year at Phoenix Fair make dog biscuits and they sell really well because most people have dogs. So if you need a Phoenix Fair idea, dog biscuits. How many cups of milk do you need per dog biscuit? So, what should be numerator? What should be denominator? What should be numerator? What should be denominator? So the question here is, what do I want 1 of? Ellie?
You want 1 dog biscuit?
I want 1 dog biscuit. So I'm going to put milk in the numerator and the dog biscuit in the denominator. So this would be 3/4, and this would be 6. But that's kind of annoying. So let's set it up horizontally. 3/4 divided by 6, and make your 6 a fraction. Then we can keep, change, flip. I do not disagree that there could be an easier way. And also, I mean, always you could grab a calculator, but that's kind of the cheater's way. And be ready for me to ask you to do these problems without a calculator. Hint, hint, nudge, nudge. Be ready for me to ask you to do these problems without a calculator. It reduces. What do we reduce by?
3.
3.
That's
not right.
28. 8 times 3 is
That's right.
24.
That's right.
That's good. You realize you could just make it make it
Hold on. My denominator is not 1 though.
Then it's not even right.
Hold on. Hold on. Here's the thing. This might be a mind-blowing moment. This is your unit rate already. Because when we perform the division, when we do this, we're essentially forcing it to become a unit rate. Because if you want to mathematically work the final step, this is 1 cup of milk will make 8 biscuits. So in order to make my denominator into a 1, to technically make this denominator a 1, how do I turn 8 into a 1? Monica?
You divide by 8 and it equals 0.125 over 1.
Now hold up. Do not go decimal. We've been working all fraction. No reason to jump to decimals. Show this work. We actually, to make the denominator 1, divide by 8 on top and bottom. And that becomes, on top we now get 1/8, and on bottom we get 1. So it takes 1/8 cup of milk to make 1 biscuit.
What?
Oh my god.
That is a lot of stuff.
But you don't have to do that last step.
You don't?
You're at your unit rate right there. We're going to do another, and we're going to see how this works out. Yeah, we don't need to do that final part. We get to the unit rate, we're done. So, try this on your own. Do not look at the screen unless you're totally confused. I'm going to write up the work. Try to keep your eyes on your paper. We're running out of time. You want eat per meal. That per meal should tell you what should be in the denominator. We're running out of time, so I get to the point of 7:30 seconds, but my denominator isn't 1, quote unquote. But guys, check this out again, because I want you to be confident on your homework. I technically have a minute, so hang on for just a second. To make this denominator a 1, I would divide by 32, and I would do the same on top, which would just get me 7 divided by 32, which is what I already have. So instead of doing that last division, we just put on the label pounds per meal. Exactly what I started with, pounds per meal, just ends up being my label.
Can you simplify that? Like 36?
No, because 7's prime.
Okay. Cool.
Yeah.
For the other part, the first one was the milk and stuff.
Yeah.
Why is it
Super sweet.
75% of 6?
Yeah, well, you'd have to take,
That's.
because you're looking for
I mean, I'm
per,
not really looking at that.
we want it per 1 biscuit, so we really have to find a 1/6 of 3/4. Since it makes 6 biscuits, we really have to take the 3/4 that makes 6 biscuits. If we divide the 6 by 6 to make it 1, we have to take the 3/4 and divide it by 6. So that's really what we did, since we needed to find a 1/6 of the 3/4. Does that kind of make sense? We're going to pick this up tomorrow.
Okay, you know,
You get it. We got